All right, welcome to parallel lines and perpendicular lines. And our objective today is to relate these to one another. So there's some really simple theorems here. Basically, this first one says that if one line is parallel to another line, and then another line is also parallel to that same line, then the two original lines are parallel. So for example, A is parallel to B, and C is parallel to B, then that means that A and C are parallel as well. Pretty simple. Then use perpendicular lines. So this one basically just states that if two lines are both perpendicular to the same line, then they are parallel lines. So that means, in this case, M and N are both perpendicular to T, and so because of that, they are parallel to one another, M and N are. So we're given then in this proof the fact that R and S are both perpendicular to T, and so you can see that right here and right here. And then what you can do is say, okay, well, if these two are right angles, then 1 and 2 are both 90-degree angles as well, and so they're also corresponding angles that are congruent. That's the word. Corresponding angles that are congruent, and those are perpendicular. Make those two parallel lines. So R is parallel to S. So that's from our previous lesson that we learned that. All right. So this case here says that a carpenter plans to install molding on a door. So if you look at like that closet door in our classroom that has the molding around it, that's what is that gray molding. That's what they're doing here, and they've mitered these this wood that's going to be here, and so a miter cut is right here, this cut and this cut, and together those make 90 degrees, 45 and 45. So because then those are both parallel to the top, perpendicular to the top, that means that this line and this line, the two sides, would be parallel. So down here, let's see if we can assemble these pieces. So if we took these 30-degree pieces and turned them vertical, would they fit right here and right here? So the real thing to do is check on these corners here. All right, poor drawing, sorry. Are those 90 degrees? So 60 degrees and 30 degrees would make 90. So yes, the corners form right angles, so opposite sides will be parallel. Okay, then this is the perpendicular transversal theorem, which basically says that if, this is kind of the other way of thinking of the last one we just talked about. So the last one said if two lines are both perpendicular, then they're parallel. This one says if two lines are parallel, so we already know they're parallel, and then one of them is perpendicular, then that means that the other one is also perpendicular. So now we're going to use those theorems to prove the relationship between these two lines here. So in a plane, we know that all of these angles, or all these lines, I guess, are perpendicular, except for we don't really know C versus A right here, because it doesn't actually extend out there and show it in the diagram. So we have to prove that through theorems. We can do that because C and D are both perpendicular to B here. So you can see C is perpendicular to B, D is perpendicular to B. And since those are two lines perpendicular to the same line, that means that these are both parallel. And if they're parallel, then that means, so if two lines are parallel to the same line and one of them has a right angle, then the other one has to have a right angle. So the answer is yes. This is proven. All right, so then the next one says, can we also prove and conclude that A is parallel to B? Well, we don't even really have to look at C in this one. We can say that A and B are both perpendicular to D, so that means that those two are parallel. A is parallel to B. So that's it. It's a pretty simple lesson today. You have some problems to do, and that's it.